Bismillahirrahmanirrahim. Hello everyone, I hope you are all fine. I welcome you all to the real analysis class. So far we discussed field and ordered field. In the last lecture I have discussed proof of some important propositions that are related to field. In today's lecture we will again discuss an important proposition from your well respected book Principle of Mathematical Analysis by Walter Rudin. This proposition is also related to the field. So this in this proposition we will discuss some additional properties that are satisfied for any field f. So proposition says that if f is any field, then for any x, y, z belong to f, for any three elements of f where f is the field under addition and multiplication, following axioms hold in f. The first axiom is 0 into x is equal to 0. That look like very simple because from your childhood, from your primary school, you know the product of any number with 0 is always 0. But here in today's lecture we will show this how 0x is equal to 0 here. So firstly we will discuss the first property, that is product of 0 into x is equal to 0. To prove the result we will use a distributive law. You know distributive law, there are two types of distributive law of multiplication over addition. One is a right distributive law and other is a left distributive law. Suppose we discuss here the right distributive law of multiplication over addition, that is a into c plus b into c. Because here we are multiplying c from right side, that's why this is called the right distributive law of multiplication over addition. If we multiply c on the left side, then it will be called left distributive law of multiplication over addition. So here we will apply this law, right distributive law of multiplication over addition, on the right side. So we firstly we consider the right side of the equation, that is 0x. That can be written as 0 plus 0 into x, because you know 0 is the identity, additive identity. So 0 plus 0 is equal to 0 here. Now applying this law here, this will give us 0x plus 0x. So this 0x plus 0x equal to 0x because your right side is 0x here, sorry, left side is 0x. Next, by using left cancellation law, 0x will be cancelled with 0x. So here there will be 0 equal to 0x. That is required to prove 0x is equal to 0. So this is the first axiom. Now we will move towards the second axiom. What is the second axiom here? In the second axiom, we have to show that if x and y are two non-zero elements of field f, this implies their product xy will also non-zero element. For any two non-zero element of any field f, we have to show that their product xy will also non-zero. To prove the result, we will use contradiction. We will consider x and y are itself, x and y both are non-zero, but their product is 0. So to prove the result, we will use contradiction. Suppose on the contrary that xy is equal to 0, whereas x and y are both non-zero. So can we write it as 1 equal to 1 over x into x, because x and y both are non-zero, so their multiplicative inverse, their reciprocals will exist in the field f. So 1 can be written as 1 over x into x, 1 over y into y. This is equal to 1, 1 into 1, that is 1. Next, by using the associative property and the commutative property at the same time, we have 1 over x into 1 over y into xy equal to 1. Now it is given that the product xy is equal to 0 by our assumption. Xy is equal to 0 by our assumption. So by replacing xy equal to 0 here, this will become 1 over xy into 0 equal to 1. That is the right side here. Now this number 1 over xy when multiplied with 0, this will give us 0. Here it is, remember that x and y both are non-zero, so this will not lead us to indeterminate form. So this will give us 0. This shows that the left side becomes 0 and this is 1 right side. 0 equal to 1, this is impossible. This shows that our supposition, our assumption is wrong, and our assumption was the product xy is equal to 0. So our assumption is wrong here. Hence, we can say that when x and y are non-zero, then their product xy will also be non-zero. This is impossible, hence when xy non-zero, this shows that. Now we discuss the third axiom, and the third axiom is the third axiom consists on three parts that are here. Negative x into y equal to negative of xy equal to x of x into negative y. So this expression has a three parts. We will prove this expression by considering the first two parts. Firstly, we show that minus x into y equal to minus x into y. Here, firstly, we consider an expression. If we shift this number minus xy to the left side, this expression will become minus x into y plus x into y. So to prove this expression, this equality, we will consider this expression minus x into y plus xy. And now we apply here right distributive law, that is y is common from right side. So yes, consider xy plus minus xy, and by using the right distributive law we have this will become minus x plus x into y after applying the right distributive law by taking y common from the right side. Minus x plus x give us 0. This will become 0 here. 0 into y. Now 0 into y equal to 0. This shows that this expression, the sum of minus x into y plus x into y equal to 0. Now next, the sum is equal to yes, we are here. Now next, in last lecture we have discussed if sum of two number is equal to 0, then the second number is the negative of the first. Mean to say, if the sum of two number are equal to 0, then both are the additive inverse of each other. That is, in other words, second number is the negative of the first. Now you can see here, this is the sum of two numbers. One number is xy and the second number is minus xy. So the second number can be written as the negative of the first. So minus x into y can be written as minus of xy. So this give us the proof of the first part. Now in the second part, what is the second part of this expression? In the second part, we have to show that x into minus y equal to minus time xy. For this, again, we use this strategy. If we shift this number minus xy to the left side, this will become x into minus y plus xy. So now we will consider this expression, x into minus y plus xy. And because you can take x as a common from left side, so we will use here a left distribution law of multiplication over addition. So this will become x into minus y plus y. Minus y plus y will give us 0 because they are additive inverse of each other. This is equal to 0. So this shows that this sum is equal to 0 here. Now again, using this result, if the sum of two number is 0, then the second number is the additive inverse of the first. That is, the second number can be written as a negative of the first. So we can write, as the sum of these two numbers is 0, so this number x into minus y can be written as negative of the second, that is minus xy. So by combining, this was our question number 1 in the first part. This is second. By combining 1 and 2, this lead us to this equation. Minus x into y equal to minus xy, and minus xy is equal to x into minus y. This gives us this. So this is the property. In the last property, property number 4, we have to show that minus of minus x into minus y equal to xy. This is our last axiom. Minus of x into minus y equal to xy. To prove the result, we will use the same strategy as we have discussed in axiom number 3. If we shift this number xy to the left side, this expression will become minus x into minus y plus minus this will become minus xy. This further can be written as minus x into minus y plus minus x into y. So to prove this result, we will consider this expression. Okay. Now when we consider this expression, now we as you can see that here minus x can be taken as a common from left side. So we apply here left distributive law of multiplication over addition. So by taking minus x as a common, or by applying left distribution law of multiplication over addition, this will become minus y plus y minus x, sorry, minus y plus y, this is equal to 0. 0 into minus x, this is equal to 0. So this total sum is equal to 0 here. Minus x into minus y plus minus x into y equal to 0. Now again, by using the result, if the sum of the two number is 0, then they are additive inverse of each other. That is, the second number can be written as the negative of the first. So here you can see here, because the sum is 0, so these are the additive inverse of each other. So one of the number, suppose we take this number can be written as negative of the first, negative of this, negative of the remaining. So this can be written as this. Now again you can use here reason that minus of minus x equal to plus x. So this will become x y, that is minus x into minus y equal to xy as required. So this is the proposition that is related to properties of field. I hope today's lecture was helpful for you, and now you have a clear understanding about today's concept. Inshallah, in the next lecture we will discuss a very important proposition that is actually related to ordered field. Okay, take care. Allah Hafiz.